So yesterday we talked about parallelograms and their angles, their opposite angles being equal. Any consecutive angles are going to be supplementary, adding up to 180 degrees. Today we're going to talk about the sides and then the diagonals of parallelograms. Most of these properties you're going to recognize from yesterday, 4 of them. First 4, we'll briefly have these, but don't rewrite these if you took your notes yesterday. Both pairs of opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. And then we said also consecutive angles are supplementary. The new thing we're going to add is diagonals bisect each other. That doesn't mean all 4 segments are going to be equal. What that means is each diagonal will be bisected. They are not equal in length to start. So when they get cut in half, obviously their halves will not be the same length. Again, the only thing we're adding is diagonals bisect each other. Some of these we're going to work through really quickly because they don't take a lot of attention. These are not marked. Here we go. Let's mark this. This is a parallelogram. We denote it this way. And since this is a parallelogram, just like we saw in our last thing, opposite sides are congruent. So if this side is 17.1, so is this side, 17.1. All right, so the next thing we want to take a look at is the algebraic portion of this. Again, these sides here, opposite sides of parallelogram are are equal. So we are going to set them equal to one another. I'm going to move the x over to the 2x, and I'm going to move the 12 over to the 2. Again, always pay attention. Make sure you answer the question that's being asked. Does it ask us to solve for x? Yes, it does. So when we have this, we are done. Wouldn't hurt to check our answer. 10 minus 2 is 8. And then 10 times 2 is 20, minus 12 is also 8. Quick little mental math. We check our answer. We know that it's now correct. Notice this one asks us to solve for the side TU. Doesn't really matter because whatever TU is, VS is. So whichever one they ask for, we were going to be good either way. These are opposite sides. So opposite sides of a parallelogram are always equal. So the first thing we need to do is figure out what x is. So I like to make the bigger variable pull the smaller. So I'm going to subtract the x away. And if I'm doing that, I'm going to add the 10 over. So we end up with 2x minus x, which is x, and negative 1 plus 9, which is 8. Do recognize this. X can be a negative number. The sides cannot be. You can never have a side length that is negative. So I have not answered the question. Remember what the question was? The question asked us what TU is. So we could go over here to TU and plug in our value of 8. 2 times 8 minus 9. 2 times 8 is 16 minus 9 gives us a value of 7, whatever unit of measurements we have. And just to check our answer, since it's such an easy equation, 8 minus 1 is also 7. So I'm moving through this section, the first section, rather quickly. If that was too quick for you, the video is there for you, so go back and look. I don't think you're going to need to look at it too very much, but it's there if you want to look at it. All right, I'm going to maximize this one a little bit, and it tells me dP has a measure of, from here to here, has a measure of 9 units, and it wants the measure from P to B. And this is the new one that we were just introduced. These are diagonals. Diagonals are cut into equal halves. This is an equal half, and this is a separate half. Now that doesn't mean anything for us on this question because all they ask us for was PB. So PB does have a measure of 9 to match the measure of DP. Again, pay close attention to these because they could have asked us for the entire line, which we may see a little bit later. Here's our fifth example. Again, equal parts here. This part is equal to this. LC is equal to AL. So when they tell me that BL from B to L has a measure of 9, that means from L to D also has a measure of 9. So LD has a measure of 9. Make sure that looks a little bit like my angle sign. I'm just straightening that up a little bit. So here we have, this is the sixth example here. We are given the value for the length xz. xz from here to here has a measure of 22.1. Well, we've already established that the intersection of the diagonals cuts these in half. So 22.2 is going to be divided into equal halves. So those equal halves are going to be 11.1. So we have a measure of 11.1 and 11.1. So when it asked me for the measure of J to Z, this segment here, we know that this is 11.1. Whatever unit of measurement we're discussing. And this is just the contrast to that. This one we are given, again, WP is equal to PY. So if WP is equal to 21.6, and then it asks me for WY, long segment, we know that this one is going to be 21.6, or we could just double our value there. Whichever way we choose to do it, we're going to end up with 43.2 for the measure of line segment YW. So we'll slow down a little bit here on our algebraic questions, but again, the concept is still the same. We're going to create these equations for ourselves. This one tells me that YB, which is equal to BT, by the way, and then we're asked to solve for the value of X on this one. So we have two congruent segments. X plus 3 is congruent to segment 2X minus 6. And all we're asked to find is X on this, so we don't have to plug anything back in. I'm moving the variables to the right this time, which means the numbers need to be moved to the left. So X equals 9. You can check your answer. This is a real quick check. 9 plus 3 does in fact equal 12. 9 times 2 is 18. 18 minus 6 also equals 12. So that's a really good sign that I have a correct answer there. X equal to 9. As we look at this one, we are told that MK, long segment, is 24 units. And it tells us that HK, from H to K, has a measure of 11x plus 1, excuse me. There are actually several different ways you can do this. You could call this segment 11.1 as well and set those equal to 24, but we've already established that the small segments, 11 point, we'll write the proof actually. We've established though that the small segments, in this case that would be HK, is equal to half the segment MK. So my statement is false because HK is not equal to MK, but 2 HKs would be equal to 1 MK. So we're going to build off of this formula. So what we do is we double HK, which we have established is 11x plus 1, sorry. And then mk, which we were told has a measure of 24. So my suggestion to you on this, we're going to divide. Instead of distributing a 2 that we're going to eventually divide back out, let's just divide by 2 right now, save ourselves the aggravation. We'll move this over here. So now we're at 11x plus 1 equals 12. We subtract 1 from both sides. So 11x equals 11. So x equals 1. Double check to make sure that that's what we were actually solving for. It was. They asked us to solve for x. So x equals 1. You can double check your answer. Real easy math. 11 times 1 plus 1 is 12. 2 12s do make a 24. All right, just a couple more slides. Hopefully this was not too quick for you. I don't think it was, but like I said, if it was, go back and take a look at the videos, pause them if you need to, whatever the case may be. So this one, we are given the value RT, which is x minus 2 from R to T, RE, excuse me. And then we're told ET has a measurement of 2x minus 14. And then they go back and ask us, what was RE? Well, again, these are diagonals. Diagonals have just split one another in half. So if they've been split into halves, that means they're equal to one another. So there we have it. We're going to move the variables to the right side this time. So the 14 needs to move to the left side. I'm going to re-emphasize the fact this is a positive answer, but I want you to recognize x's can be negative numbers. The lengths cannot be. So x equals 12. X equals 12, but they didn't ask me for x on this one. They asked me to find RE. RE's got a nice little formula to work with 12. RE is x, which in this case is 12, minus 2. So RE would equal 10 units. So this is our answer right there. I'm going to check my answer real fast with the ET, because it should also be 10. 2 times 12 is 24, and 24 minus 14 is, in fact, 10. So there's my checking of the answers. And our last example for today. We are told that VP has a measurement of 20x plus 1. And then we're told that VT, long segment, has a value of 41x plus 1. So we've got two options here. We can either cut the VT in half, or we can double the PV. Now, cutting 41 in half and cutting 1 in half is not a favorable outcome for us. So instead of cutting the big one in half, what we're going to do instead is double the small piece. So 2 VPs would equal 1 VT. So we know that VP has a measurement of 20x. Get that? 20x plus 1 equals the VT amount, which is 41x plus 1. So if you think back to the example we did last time, you remember I divided by 2, but dividing by 2 is not favorable on this one because that would end up giving me decimals. So I am going to actually distribute on this one. We'll take these case by case to see which way is best, because it's sometimes hard to tell just by looking at it at the beginning. So we end up with this. I'm going to move the variables to the right side. I always make the larger variable pull the smaller one. If you're wondering why I do that, it's because I don't want to end up with a negative variable. It's not the worst thing in the world, but why not avoid it? So I move the variables to the right side, so I need to move the non-variables to the left side. So I subtract this. 2 minus 1, of course, is 1. So x equals 1, but they didn't ask me for x. They asked me for VT. And VT had a measurement of 41x plus 1. We just established the variable x is worth 1, so VT equals 41 plus 1. VT equals 42. So if VT is 42, just to check my answer again, the smaller segment should be 21. So when I plug in 1 to this, I can do this math mentally. 20 times 1 is 20, plus 1 is 21. So there we have it. You guys have an example that you're working on. Good luck.